Hello viewers, I am Kausalya. Today we are going to solve problems related with reciprocity theorem. So here, to explain what is meant by reciprocity theorem, we will go with this problem, right? So here, we will be having only one current source, right? Not like a superposition theorem. In superposition theorem, we will be having two sources. But here, there will be only one source. You see, initially, let the source be in its original place and we will be finding the values of whatever thing asked in the problem. For example, here, you see here, we are asked to find I3. Right. Whereas in the next step, we are going to shift this 10 voltage source to the some other branches. Right. And again, we are going to calculate the same I3. And finally, we are going to check whether the value of I3 remains the same. Right. So, we will go with this problem. When one problem is completed, you will get a clear idea about what is meant by reciprocity. Right. So here the problem is, for the circuit shown in figure below, find I3 and verify reciprocity theorem. So this is the given circuit diagram, and in the circuit diagram the direction of the currents are already mentioned, right? So here I1, I2 and I3. So depending upon the name of the current given here, so let this be loop 1 and let this be loop 2 and let this be our loop 3, right? So first we are framing matrices. So in matrix form, so the general representation is V is equal to I into R, right? So V, when you consider the voltage here, you see I'm having only one voltage source, and again the direction of current in this loop is, again you see it flows from minus to plus, right? So therefore here the answer is 10 volt. So here this is 10. Okay, in loop 1 we are having a voltage source and the current direction is from minus to plus, therefore it is plus 10 here. And again in loop 2 and loop 3 there are no voltage sources, therefore they are represented as 0. Right. And the next thing is current. So as usual, the current flows in loop 1 is I1, loop 2 is I2 and loop 3 is I3. Right. So here we have written as I1, I2 and I3. Again, as usual, to find the value of resistances, this diagonal elements, what does this diagonal element represents? The sum of the resistance present in that particular loop, right? Since we are having 3 loops, here we are framing 3 by 3 matrix, right? And here again, to make it further better, you just write the names 1, 2, 3, right? So 1, 1, 2, 2 and 3, 3, we should add the resistance present in that particular loop. So the sum of resistances present in loop 1. So this is your loop 1, right? This is your loop 1. So 3 plus 10 plus 1, that gives 14. So this is what I had written here. Similarly, when you consider loop 2, 2 plus 10 plus 2, that is again 14. So here I had written 14. Again, when you look at loop 3, 3 plus 2 plus 1.375, that gives an answer of 6.375, right? So we have filled our diagonal elements. Now the next thing is the element which is common between 1 and 2, right? So this is your loop 1 and this is your loop 2. So what is the resistance that is common between loop 1 and loop 2? It is 10 ohm, right? Now look at the current direction. So here the current flows like this, right? And again when you consider I2, the current flows in the same way. Therefore the value here is plus 10. So between 1 and 2, you see 1 and 2, here I am writing plus 10. Now consider 1 and 3. So when you consider 1 and 3, what is the resistor which is common? Again it is 3 ohms, right? Now look at the current direction. So when you look at I1, you see it flows like this, right? Again, when you look at I3, it flows in the opposite way. Therefore, here it is represented as minus 3, right? So, once this row is filled, you can fill this column. And the next thing is the element which is common between your loop 2 and loop 3. So, again, when you look back, so this is your loop 2 and this is your loop 3. So, which is common? Again, this 2 ohm is common. Now again look at the direction. So I2 flows in this way, whereas I1 flows in the way that is exactly the same. You see, I2 flows like this. And again I1, I3 also flows like this. So therefore it is plus 2. Right? So finally we had framed the matrix representation. Then the next thing is we are going to calculate the value of del. So here the del is given by, we are going to take this resistance matrix and calculate the del value. So again this forms the basic mathematics, I believe you people know. So plus, minus and plus. So when you look at 14, okay, you just write 14, you have to hide this column and this row. So 14 into 6.375 minus of 2 into 2. Okay, that is your first expression which is written here. And the next thing is here we are having a minus, right? So minus 10, you have to write it as minus 10 here. Then the next thing is you have to hide this one as well as this row. So what comes next? 10 into 6.375 minus of minus 3 into 2. So that gives the answer like this. And the next thing is here it is minus 3. So plus into minus, again it becomes minus. So minus 3 of, the next thing is 10 into 2 minus of minus 3 into 14. So here this is what the expression, right? We have completed all this. Just simplify and finally the value of del is calculated as 310, right? Here we are asked to calculate the value of I3, right? Therefore here the next step is we are going to calculate the del 3 here. So how to calculate del 3? First, you have to frame matrix for del 3. That is, you have to replace this third column with this voltage values, right? So here we had framed del 3, right? So now just calculate the value of del 3. It is 620. Again by the same way, right? Plus, minus and plus. And I3 is nothing but del 3 by del, which is nothing but 620 by 310, that gives 2 amps, right? So now the step 1 is over. Now we are going to proceed with the step 2. So now we are going to transfer our voltage source, right? You see, now transferring the battery or voltage to the branch with 1.375 ohm resistor, right? Now the current through 1 ohm resistor is taken as I3. So here the thing is we are just reversing the entire circuit. We are transforming the voltage source as well as we are changing the current that flows through different loops. So here you see, initially our voltage source lies in this place. Now I have transformed this voltage source over here, right? So the place, that is the loop which holds the voltage source, is assumed to have the current I1, because when you look back, you see here is our voltage source, right? Therefore here this loop is considered to be, that is this loop current is considered to be I1, right? So here this is our I1, right? I2 remains the same and here this becomes I3, right? Can you understand? We have transformed the voltage source from this loop to this loop. Therefore, the loop which contains the voltage source is assumed to be having a current flow of I1, right? And this I2 remains the same and here we are moving with the I3, right? So, again the direction of flow we can assume by ourselves. Since we are having a voltage source, let the current flows from minus to plus, right? So I1, I2 and I3. Okay, I2 and I3 we are taking by our own. So the next thing is framing the matrix. So when you frame matrix, this first loop has only one voltage source. Loop 2 and 3 have no voltage sources, therefore 0. And the currents are respectively I1, I2 and I3. And as we all know, as usual, the same way to frame our resistance matrix, right? So this diagonal element, okay, this diagonal element, it is nothing but summation of the elements. Okay, when you look at loop 1, 1, when you look at this loop 1, right? So the summation of resistors are 1.375 plus 2 plus 3, so which is nothing but 6.375. Again, when you look at loop 2, 2 plus 10 plus 2, that gives 14. Loop 3, again 3 plus 10 plus 1, that gives 14. Right. Again, the resistor which is common between loop 1 and loop 2 is 2. So here I1 flows in this way, whereas I2 flows in opposite way. Therefore, that gives minus 2. And between loop 1 and loop 3, the resistor is 3. And here the current flows in this way, and here the current flows in opposite way. Therefore, here it is minus 3. Again, when you consider between loop 2 and 3, 10 ohm is common. And I2 flows in this way and I3 flows in opposite way. Therefore, it is minus 10. Right. So finally, we had framed our resistance matrix. So the remaining steps are as usual. Just calculate del. Right. So the value of del is again 310. When you go for del 3, again you have to replace this third column by voltage source. So when you replace here, we are having del 3 like this. The same way, right, again plus, minus and plus, just calculate the value of del 3. This is calculated as 620, and therefore the value of I3 is del 3 by del, which is 2 amps, right. So in step 1 also, we are having the value of I3 as 2 amps, right. So again in step 2 also the value of I3 is 2 amps, right. Therefore, for this circuit, the reciprocity theorem is verified, right. So here comes the end of this video. I hope I made you understand the concept. So if you have any doubt, let me know in the comment section. Thank you.